This is a presentation on how to repair small damaged eggs and assist with hatching. It is being presented by Andrea Kabibi. Now, the emphasis in this PowerPoint presentation is small eggs rather than the large ones, since they do present additional challenges that you don't encounter with larger eggs. However, all of the principles within this presentation do apply to the larger eggs. Now, one of the things that happens with the small eggs is that you can lose structure and rigidity, especially if you're trying to do an assist hatch, as you can see here with the larger eggs. There is difficulty in handling in that as you break into the egg, the rest of the eggshell will crumble because it loses its rigidity and its structure. There's also difficulty in monitoring the internal pip, and I'll go into that a little later on because of the tiny size of the eggs. And also, the longer you handle them or try and assist with hatching, the more rapidly the small eggs will cool, and the chick will become torpid or damaged from the cooling of the egg. Now here you can see a Ruppel's vulture. This was assisted out of the egg. Here is a California condor that was malpositioned. We'll talk a little bit more about that later. And here you can see a common canary that's been assisted out, and the sheer tininess of the egg and what you're dealing with. And again, we have some finches here, Gouldian finches, and again showing the extreme size difference between handling the larger eggs and handling the smaller ones. Now, before we go too far, we should cover the anatomy of an egg. It's most important to understand what's happening within the egg as the chick develops, so you can better understand when to go in and assist with hatching. Now, the important part is the head develops at the large end of the egg, and that is where the air cell or airspace is. The membrane encapsulating the airspace drops as the chick develops. And its first pip, which is called the interior pip, is where the chick actually pokes its beak into the air cell and takes its first breath. The second pip, also known as the exterior pip, is where you see a little chip where the chick is actually chipping its way through the shell and showing a pip on the outside of the shell. Now, during this whole process, blood vessels that are surrounding the membrane starts to retreat and shut off so that the chick doesn't bleed to death as it breaks through. The egg yolk, which is also on the outside of the body, is drawn into the body as the chick is getting ready to hatch. And you can see on the right-hand side how large some of these blood vessels are and how much of a egg yolk needs to be withdrawn into the body. And this is really important because your timing for breaking in has to coincide when these things are occurring, that the blood cells are retreating and the egg yolk is being withdrawn into the body. Otherwise, one of those blood vessels could get ruptured and the chick could actually bleed out. Now, a little further to understand the hatching process here. So on the left-hand side, you can see this is a typical chicken egg, and you can see that the membrane, which is encapsulating the air cell, on the 7th day is fairly high up. 14th day, it starts to lower down. 18th day, it's actually draping over the top end of the chick. And it's this membrane that the chick will be pipping through for the first internal pip. On the right-hand side, you can see the what we call a zipped egg, and that means that the chick has actually rotated and chipped far enough around the shell that it should be able to pop the top off, which you can see at the bottom is a fully zipped egg. The pipped egg is one that is just showing the initial first pipping or first little hole where the chick is attempting to get out of the shell. Now, as I said, the internal pip is where they come through the through the air cell into the inside of the eggshell to get their first breath. Now, in the lower left-hand corner, you can actually see with the candler, you can actually see the chick's beak in the air cell there. And with larger eggs, this is very useful for letting you know where the chick is at in the hatching process, if it's running into problems or if it's malpositioned. With the tiny eggs, like the finches and the canaries, it's very hard to actually observe that internal pip because everything is so small, including the tip of the bird's beak. Now you can also see on the left-hand side how the air cell has been drawn on the egg as it's progressed, and it's showing how it's slowly sagged down until it's draping over the top of the chick. And the first pip, as you see on the right next to it, the pipping egg, the first pip will look like a slightly raised or cracked area on the surface of the chick. Now, one thing that's really important is that the chick is in the correct position to actually hatch. And we're going to go into that a little bit more. If it's not in the correct position, which is basically the beak under the right wing, and the chick will actually rotate counterclockwise or anti-clockwise as it goes through the pipping process. And this enables the beak to come up into the air cell and then eventually come up into the edge of the shell so that it can pip its way through. So normal hatching position, head is under the right wing and the chick turns counterclockwise. This puts its beak into the air cell where it needs to be. And on the left-hand side, you can see the silhouette showing the beak in the air cell through a candler. Down below, you can actually see the beak poking through the membranes. And you can also see how many blood vessels are still surrounding the membranes at that point. So if you were going to try and assist hatch this chick at this point, you could very likely break one of those blood vessels and the chick would bleed out. And on the right hand side, again, you can see this is a normal hatching position, and this goes for all species of birds. This is the position it needs to be in to actually hatch successfully. Now, having talked about normal position, we can now refer to what we call malpositioned chicks. And one of the things you need to keep in mind is a normal position chick, unless it's very dehydrated or there's another issue with it, they will hatch out without assistance. Normally, when you're going in to assist a chick with hatching, as we are with this condor chick here, then most of the time the chicks are malpositioned and their beak is not where they should be. So that means that the chick is unable to reach the air cell. It's also in the wrong position to zip the shell open, and it's also unable to turn counterclockwise. Now, if you look on the left-hand side, you'll see various examples of malposition. The dotted line on the right-hand side is the air cell draped over the chick, waiting for the chick's beak, but the beak can't actually reach it. Now, the picture on the right is showing a malpositioned condor, and that is actually number 2, which you can see on the left, is the beak was actually under the left wing and the chick was upside down, in that the chick's head was at the small end of the egg and would never have reached the air cell. So the chick eventually would have died if we weren't able to break in and reposition it. So how do you tell where the beak is? Well, if it's a large egg, sometimes you can tell by candling, but most of the time that can be very, very difficult. More advanced techniques, which are not usually available to most of us, is to actually x-ray the eggs. And you can see some examples here. The X and the O are put on there so that the radiographs will show them, and you can later try and find the position in relationship to the XO on the actual egg. So the green arrow points out where the beak is on all of these x-rays, and on the right hand side it points out where the beak is on the malpositioned chicks. Now, one of the things you're going to notice is how incredibly unclear these x-ray images are. And the reason for this is that the bones of the chicks have not fully calcified while they're in the shell. So the bone density is very not very dense compared to an adult or even a hatched chick. So it makes x-rays very difficult to actually read, and it takes a lot of skill to be able to read these x-rays and figure out what is actually going on inside the shell. So let's get back to the smaller eggs and some of the issues that are associated with handling the very small eggs. When you're dealing with them, it's really important to work very quickly to prevent cooling of the egg. They will cool very rapidly, and this can damage the developing embryo or the unhatched chick. It's a good idea to work on either a heated towel from the dryer or an electric heating pad set at low or medium to keep the egg warm while you're working with it. But again, you should minimize handling as much as you can so that the egg doesn't become chilled. Also minimize handling because at the end of the incubation process, when the chick is ready to hatch, it's taken a lot of the calcium from the shell to form its own bones. And that means that the shell is actually at its thinnest when the chick is closest to hatching. So it's very easy just by holding the egg or grasping it too harshly to actually crush the eggshell at that point. Use a good candler to try and assess the internal pip. You can sometimes see it so that you know if the chick is malpositioned or if it's just progressing fine and it has actually taken its first breath. Now, I highly recommend the fiber optic candlers that we do sell on our website. They're absolutely awesome. They have cyan bulbs, which are really bright, and the fiber optic curved tip allows you to not only candle the eggs within the nest without touching them, but it also ensures that the tip of the fiber optic tube is cool, so there's no heat being applied to the egg, but you still get a nice bright light. Now, another thing you should always keep in mind, just under the candling photograph on the left there, that is the outside shell of an egg, and you can see it's completely porous. It's got zillions of little microscopic holes. So what does that mean? It means that any moisture from the outside can be sucked into the egg and affect the embryo. It also means the egg is able to evaporate moisture, respiration from the chick through the holes. So basically, the egg is very, very interactive with its environment in respiration, exchange of gases, and exchange of liquids. So this means when you handle your eggs, make sure your hands are extremely clean and disinfected before you touch them, because it's very easy to put some very bad bacteria on the surface by touching the eggs with dirty hands, and that gets drawn into the tiny developing embryo within the egg. The other thing is, if you decide to clean your eggs or clean, dirt off the surface or feces off the surface, use sandpaper, a little bit of very, very fine sandpaper. Don't ever use water, because water, as soon as you put water on the surface of the egg, it will get drawn into the egg. And if there's bacteria on the surface, or if you happen to be cleaning off feces, it will draw all the bacteria from the feces straight into the egg to the embryo. So don't use water to clean your eggs, and don't handle them unless your hands are very clean. Now, I want to go on and talk about the Egg Buddy, which you can also is available on our website. And this is an absolutely amazing piece of equipment. It is used to monitor the heartbeat of the chick within the shell. So your unhatched chick, you can use it to assess whether your egg is actually fertilized or fertile, but you can also use it to monitor chick distress as you're nearing the hatching process. So basically, what it will tell you is whether the chick has a normal heart rate or a normal heartbeat, if it happens to be overdue for hatching, which is generally running between about 250 and 300 beats a minute. If it does, you don't need to break in. If you take an egg that's late in hatching and put it in the egg buddy, and it's starting to show you a dropping heartbeat of, below 100 or heading down to 70, you know that that chick is in distress and unable to get out of the shell, and it's getting weaker and weaker. At that point, you can break in, or you have to break in, otherwise you're going to lose that chick. So the egg buddy is an absolutely incredible tool for anybody's bird room to be able to tell you where the eggs are at in development, how the chick is doing inside the shell, and whether you should consider breaking in. Another very useful piece of equipment on the right-hand side at the top is a cauterizer, and this is also available on our website. It's for nail and beak bleeds, and it stops the bleeding instantly. It's also a very useful tool when you are breaking into an egg to assist a chick that's having difficulty hatching, because if you do nick a blood vessel, you can cauterize it and stop the bleeding. And this is only on the edge of the shell. You don't use this for, the chick itself. You just use it for the blood vessels that are still part of the membrane on the shell. So it's a very, very useful tool to have around, and it also stops nail and beak bleeds instantly. And down the bottom, I'm just showing a metal teaspoon or half a teaspoon. I use this to lift up little tiny eggs, and one of the reasons is it stops me handling the eggs, and it also has a very fine edge, so I can scoop them up really easily and just carry them to the egg buddy and tip them into the egg buddy without damaging them or contaminating them with bacteria, and I can transport them around, and this is what I usually use for carrying the small eggs. So now on to how to repair broken eggs. Now I've got a couple of examples here, and this particular technique is what we use in the zoos, and it's good for repairing small punctures and small cracks. Now there is a size limit, and on the right hand side that is kind of the maximum amount of damage that you can repair by this method. If you have more damage than that, we'll go onto that in the next slide. So basically what you use is shellac, which again is also available on our website and with the egg repair kit, which I'll talk more about later. This is a completely non-toxic sealant that you can seal the hole up so that bacteria can't get in it and there won't be further damage. Now, one of the things to remember when you're using this is it will fill the pores associated with that hole. So if you put too much around the hole, you only need enough to just fill the hole and seal the hole. If you put too much around, what will happen is you'll affect the evaporation process, which is natural in the egg, because you'll have filled those pores, those microscopic pores that are in the shell. So you want to use the minimum amount of shellac that you can to try and repair the damage without covering too much of the shell. Now on the right hand side, you can see we're using a little bit more. We're just applying it there. You let it dry afterwards, and you can return the egg to the hen or the incubator, whichever you're doing. And what this does is it completely seals off the egg, the crack. It stops bacteria from entering the egg, and it also stops any fluid inside the egg from leaking out. And it is completely non-toxic to the developing chick within the shell. Now we're going to look at some more severely damaged eggs here, and you can see a much larger dent we're showing on the left-hand side and also in the middle there. And these, you can't just use the shellac. You actually have to provide a patch with these ones because the shellac doesn't have enough structure to stop the egg from continuing to crumble here. So what you do is you take pieces of Kleenex, and this should be just basic Kleenex, not the ones with the sneeze shield or aloe vera or whatever it is, just basic uncontaminated Kleenex. And you cut it up into tiny little pieces that are going to cover the dent or the damage to the shell just a little bit over the edge. Again, you don't want to cover too much of the egg because you'll affect not only the ability of the egg to exchange gases and exchange moisture, but you'll also affect the ability of the chick to actually pip out of the egg and hatch on its own, because it won't be able to get through too large a patch. It won't actually be able to chip through it. So keep your patch to a minimum. It should cover your dent and just a little bit over the edge. And what you do is you, first of all, put on some of the shellac over the dent or the damage, or in the other case, the actual puncture wound or puncture hole in there. You put it over, you put the shellac on, then you place your little piece of tissue paper over it, then you put the shellac on again on the top. And again, this is non-toxic. And by the way, this is not the shellac you get in a hardware store. And the other thing is, a lot of people think that they can use nail polish, nail varnish, and various other things. Don't use those. They all have thinners or acetone in them, and that again will go through all the pores in the shell and is toxic to the chick. So important about this stuff is it is non-toxic, and it does seal what you need to be sealed. It also doesn't provide such a hard surface that the chick still can't get through. So this is how we would repair a larger damaged egg, is using plain Kleenex with shellac. Now, here I've given an example. This is a kakapo, which is a very highly endangered parrot, and this is an absolute extreme repair effort, and normally this wouldn't work because the tape that they've used, the masking tape, the chick wouldn't be able to get through it, and on top of that, the gaseous and exchange and evaporation process, which is normal for hatching, wouldn't happen. But by luck, this particular egg, which a ranger apparently found in a forest, was very badly crushed and damaged, but the chick was also very close to hatching. So what they did is took strips of masking tape just to hold the structure together until the parrot could hatch. Now, also lucky is that the bird, when it started to try and pip out of the egg, it chose a spot where there wasn't masking tape on it, and it was able to take the top off and hatch successfully. So the example here, although, it's not recommended to use masking tape, is just to show how much is actually capable of saving eggs, how you can save eggs no matter how damaged they are. It's always worth the effort. So next question is when to actually begin to assist with hatching. How do you know when the chick is running into trouble? Obviously, the egg buddy is absolutely invaluable, because if your chick is overdue for hatching, you can put it in the egg buddy heart monitor, and it'll tell you whether your chick is tiring or becoming weak by checking on the heartbeat, and whether it needs assistance, or whether it happens to be late and the chick is good and strong in there and you don't want to break in. But one of the ways that we do figure out how to assess exactly when we should begin assisting with hatching is what's called the pit to hatch period. And this varies according to species. So I can tell you for a California condor, the first internal pip to the moment when it should begin hatching out doing an external pip is 72 hours. For a canary, from my experience so far, it appears to be between 20 and 24 hours, but I don't have it exactly timed yet. So here's a problem with the smaller chicks is you can't easily assess that internal pip. So you can't tell when that's actually started, but if you're keeping good records and you know when that chick went or when that egg went in to be incubated, then you should know exactly when it's due to hatch. And again, I can't stress enough how useful the egg buddy is, because it will also tell you whether your chick is running into trouble because it's malpositioned. So one of the important things is don't break in too soon. And here's the reason. The chick, when it first hatches, and this goes with reptiles as well, it first pokes its beak into the air cell and takes a breath. And that breath is very important for it to attain the energy to continue to pip. However, it's important that the chick runs out of oxygen, because what happens then is the carbon dioxide builds up in the chick's body and it causes spasms or seizures. And it's actually these seizures that enable the chick to rotate in a counterclockwise position and peck at the outside shell. So the seizuring or the lack of oxygen is also a normal process of hatching. If you break in too soon and you give the chick oxygen too soon, it won't have the seizures, therefore it won't have the strength to continue to hatch. So very important not to break in too soon. It's actually normal for the chick to run out of oxygen, begin to seizure, and that causes the pecking action as the chick goes round in the shell. Also important to allow rest periods when you're actually breaking in to the shell. Down below, I've given a demonstration. This was a malpositioned canary chick that I did break in and I assisted with hatching. You can see a little bit of blood on the shell piece that I've taken off there, where a blood vessel did get ruptured, and I cauterized it to stop it. And then once I got the chick some air, I allowed it to rest for a while, because again, there were blood vessels that needed to go through the process of retreating, and the egg yolk was still external to the chick. So the egg yolk needed to be pulled into the body. Then about an hour later, I went back and I lifted out the head of the chick. Another hour, I allowed the chick to roll out of the shell on its own. And on the far right, you can see the chick is starting to move on its own as well. So this was a very successful assisted hatch, but don't get carried away and think that you need to complete it very fast. I mean, hatching takes time. Sometimes it can take up to 24 hours for the whole hatch to complete. So when we break a chick out, as it's called, or assisted hatching, here's a couple of very important things to remember. The membrane that's surrounding the chick can become dry very quickly when you're trying to break out a chick. Now, a lot of people think, oh, you can apply water. Do not use water. It makes the drying far worse, and it turns that membrane into almost like a dried leather that the chick can't get through. If you want to apply moisture to the membrane, use what's called artificial tears, and it should be the oil-based artificial tears. You put a little bit in a cotton swab and you use that to moisten the membrane, and it's made for our eyes. It's also the correct balance, pH balance and everything for the membrane, so it doesn't make the drying worse as water does. So by lightly moistening the membrane, you can also see the location of the veins a little bit better. So in this particular case, if you were trying to get air to this chick, you can see where the beak is, but you want to make sure you don't cut into a vein. So by moistening it, again with the artificial tears, just a slight amount, you make the veins very visible, so you can actually see where not to cut in and where you can. Another thing to keep in mind is that applying some gentle pressure or light rubbing with the cotton swab will actually reduce the refill rate of the vein and makes it safer to break into the membrane. So if you do see only veins there and you have no option, then just apply some pressure and rubbing with the cotton tip, and it'll actually seal off the vein so that it doesn't bleed when you cut into it. So here's another example of assisted hatch, and this is a Greenwing macaw, and you can see the low pip. It's where the bird is actually pipping in the eggshell, and it's very low down. So that's one of the signs that this bird could be running into trouble. The pip should be much higher up into the air cell area. So basically they opened the area without damaging the membrane to confirm the position of the beak and allowed the vessels to retreat, and they also saw that the chick had actually not pipped the membrane at that point. They gradually opened the membrane and the beak was able to get through to actually establish breathing. They could tell that the chick wasn't ready for hatching, so they sealed it back up with surgical tape, which you can do. Little more difficult with really small eggs. As I say, with big eggs, you can get away with an awful lot more than you can with the little ones. Once they'd freed the head, again, the chick was left to relax and rest and absorb the rest of the blood vessels in the yolk sac, and then continued to hatch on its own, as you can see on the right-hand side. So here I'm going to play a video. This is going
about
to show
the technique that you can use to break into a very
demonstration.
small egg. This particular egg is a canary, but you could also use it for finches or anything else. And the reason to break in is when a chick is having difficulty hatching and you know that it's still alive, but it can't get out of the shell. Now, one of the first things that I do is I take this egg shellac, which is produced by Taxonics Science Incorporated, and I coat the shell. And the reason that I do this is that once you break in to the air cell end of the egg, then the rest of the egg loses its structure and rigidity, and it will crack. And what will happen is if there's any blood vessels still attached to the live chick that's inside the egg, then the chick will bleed out when the egg cracks around it. So the other thing I don't want to do is I don't want to handle the egg, because again, as I break into the air cell at this end, the egg loses its rigidity and its structure, and any pressure that I'm putting on the shell will actually cause the eggshell to crumble, and again, potentially for the chick to bleed out. So what I'm doing with this shellac is I'm actually coating the lower end of the egg. So it's basically about 3/4 down. I don't want to coat the area that I'm going to be breaking into. I just want to coat down here to give some solidity to the eggshell when I actually break in. And this special shellac is non-toxic to the chick inside. Always keep in mind that an eggshell is completely porous. It's filled with little holes. And what we're doing here is actually filling the holes. And because it's non-toxic, the chick is okay. However, if we were going to be leaving this egg for any period of time, this would not be good, because any gaseous exchange between the egg and the atmosphere that needs to be done can no longer be done with this shellac on it. So I've coated about 3/4 of the way down, and now I'm going to put an extra glob on my piece of paper towel here, carefully roll my egg onto it so that it actually adheres to the paper towel and makes it easier for me to manipulate the egg itself. So the reason we don't have to worry about the fact that the egg is no longer able to exchange gases with the egg shellac on it is because we are going to break this chick out. So basically, while I'm waiting for that to dry, I'm going to explain a little bit about the instruments that I have here. These are all included in the egg repair and breakout kit produced by Taxonics Science Incorporated, and it contains a couple of bottles of the shellac, egg shellac. It has this tool, and this is what I use for actually breaking into the end of the egg here. It's nice and long and solid and gives me a lot of stability for very fine work. There's some very fine-tipped tweezers here. There's a membrane under there, and I use those sometimes just to grab the membrane to tear it slightly so that the chick can begin to get air, because it is alive inside while you're trying to break it out. Scissors, again, sometimes I'll use those for the membrane or to cut a little bit of the shell away. Don't usually use those too often. And then the other thing I have here is a cauterizer, and basically you press this button here and the end of it becomes very, very hot. I use that. Sometimes when you're breaking into the end, if you're a little bit early, you may break a blood vessel that's actually going over the air cell end of the shell. And you can stop the bleeding by just very gently touching this to the area that the vein has actually been broken. So I use this to stop bleeds at this end. Now obviously going down here, if the shell were to crack, I can't really stop the bleeds down there because I don't want to touch or burn the chick. But at this end, it's hollow and there's nothing in there. It's only the air cell. So by this time, usually it takes a lot less time, the egg has adhered to the paper towel. Now, one of the advantages of this is I can actually, as you can see, I can manipulate the egg without actually touching it, so I can see what I'm doing in here. Now, one of the things I will let you know that this chick inside this shell is actually, it's a dead-end shell. When I'm doing a live chick, I don't have time to explain what I'm doing, so I'm actually showing this on a chick that I know is already dead in shell, and I'm going to show you how to break in. Now, I would highly advise that you do the same. When you get a chance, practice on infertile eggs, practice on dead in shell eggs, and learn to get the actual end open and manipulate the membrane and the chick itself where you possibly can before you have to do the real thing. So now we're going to start, as I say, it's adhered. We've got our shellac coating on the lower 3/4 of the shell, and now we're going to start breaking in here. Now, again, I don't want to grasp the egg because what's going to happen is as it loses its structure, then whatever pressure I'm putting on it will crack it all the way through. So I use this and I just very gently punch little holes in the top. This end of my finger is just holding the egg in place, and I'm just slowly just breaking in to the very top. As you can see, that's now come off, and now I'm actually in the top of the air cell. And I'm going to turn the egg around. Hopefully you'll be able to see a little bit, and you can actually see right inside there. And we've managed to prevent any break happening where we don't want it. Now, if I want to widen the hole, I can use the tweezers. I can either push them out like this just to crumble the edges, or I can use them like this just to pick away until I get down to the membrane. Now, as I said, this is a dead-end shell, and as far as I know, it's a fully formed chick. Now, what you see there is the membrane. This is the membrane that the chick has to get his beak through in order to be able to breathe through the air cell. This is a late term. This is full term development as far as I know, and probably a malpositioned chick. So now, what if this chick were live, you can see the membrane. Hopefully you can see it on the camera there. And I'm going to pick very gently at the membrane to try and break it open for the chick to take a breath. Now I'm going to have a look on my side, and it's kind of wet in there because, as I said, this is a dead-end shell. But this demonstrates how you're going to break your membrane, how careful you need to be, and how you can still have a look, manipulate your egg because it's actually adhered to the paper towel. So these are the tools that you need, and as I say, practice with your dead-end shell. Practice trying to break them out without cracking the egg. Now, normally what I do, I break this end. I'd make sure the membrane was open so that the chick had some air, and then I would leave it for a couple of hours. I would put it in an incubator, and I would leave it at a temperature of about 102 and let it rest, and also give it a little more time for the vessels to retract so that the chick won't bleed out. Then I'd come back later, bring it back more, and check how the chick is doing, and then start to crack it down the sides. But the main thing is get the chick some oxygen. So hopefully that's been useful, and that is the end of my demonstration. Get the chick some Okay, I'm going to be
Now I'm also going to
demonstrating
give a
the
demonstration
Egg Buddy,
here
which is a
of the
digital
Egg Buddy
egg heart
digital
monitor.
egg heart
It's really an
monitor and
amazing
how
piece of
that
equipment to
works.
have in your bird room, and it's not actually that expensive. Now, right here, you can see I turn it on, and on here you have a line here showing what's going to be the heartbeat of the young canary. I have a fertile egg of canary chick here that I'm going to place inside and close the lid, and then you're going to be able to see the actual heartbeat of the bird itself. Here it goes. You can see it's up to 335 beats a minute. This is telling me that this bird is very healthy in here. It's fluctuating a little bit because the bird is actually moving inside the shell. 335, it seems very high, but it's actually normal for a young canary chick. And I know now that this bird is doing well. If it were an abandoned egg, I would put it in here to see if the chick is still alive. Now you can see it zeroed out there. That basically just means that the chick is moving too much. You can see the little bird with the wing going up and down. The chick is actually moving too much for it to grab a heartbeat, and probably because I've disturbed it, but you will see the heartbeat come back on, and you can see the motion of the heart there. Here it goes again, 291. It is slowing down, and it will slow down as the egg chills. So I'm going to leave the demonstration as it is, and hopefully you'll be able to see you can use the heart monitor on many different sized eggs. It's got 3 sensors here that are used to actually detect the heartbeat of the Egg Buddy. So if you're on Facebook, please like our page at Taxonics Science Incorporated, or come visit our online store at www.cabibiscanaries.com, and that's CABIBISCANARIES.com. Thank you.
Okay, well that concludes our presentation on repairing eggs and assisting with hatching. The Taxonic Science Incorporated Egg Repair Kit is available online, and you can see here some of the tools that are included with it, including the egg shellac. The cauterizing tool is sold separately, but you can also get that at our online store, and that's www.cabibiscanaries.com. Thank you.